It is currently 8:11 p.m. on a Tuesday, which means it's time to record math. Put it on YouTube. Let's get started. We're going to go over one of many videos on how to graph parabolas. We're going to be looking at a certain form of parabola. Some have been known to call it Vertex form. But really what it is it's a way of graphing parabolas where it's just the parent function transformed. Now, we're going to be doing lots of parabola graphing today. We're also going to be refreshing our brains of what we learned about graphing before. And that was graphing the function y equals the absolute value of x. We did lots of transformations with the absolute value of x. We shifted it left, shifted it right, shifted up, down, blah, 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 blah. Okay, you get the picture. What we're doing today is not new. All we're doing is shifting left, shifting right, shifting up, shifting down, stretching, reflecting. We're doing all of those things, but we're just doing it with a different function. Which function, you might ask? I'm so glad you asked. With the parent function for the quadratic equation. It can be written like this, or you could write it with parentheses. That won't change anything, okay? The reason I'm writing it with parentheses, which is kind of redundant, is to show you that there's an inside of the function, inside the parentheses, outside the parentheses. We don't always write them, but when you see just a lone x squared like this, you can imagine there being parentheses around it. So what does this function look like? Now, we've seen this before. Graph it one more time. The parent function of a quadratic is you take all the x values and you square them, and that's how you get the y value. So 0 squared is 0, 1 squared is 1, 2 squared is 4, so on and so forth. Feel free to speed this part up. It's not going to take too long. 4 squared is 16. You get the picture. So 0, 0 is one of the points, right? 0 squared is 0, 1 squared is 1, 2 squared is 4. So the heights are just the x value squared. 2 squared is 9. Now, it turns out that the parent function, you need to have this seared into your skull, okay? It needs to be seared into your skull so that you know exactly what this looks like. And really, you just need to remember these first, most of the time it's just the first couple numbers, 1, 0, 1, 4, 9. The first 3 perfect squares, maybe a couple more after that. And you can graph like any quadratic that's been transformed. And we're going to use this over and over and over and over and over again. So all we do here is we know that our axis of symmetry for the parent function, that lowest point, 0, 0, is our vertex. Our axis of symmetry is the line x equals 0. And our vertex is 0, 0, which is, I think I just said, so I'm repeating myself. Now we can take all these purple points and we can reflect them. As parabolas are symmetric, but mathematically you would see that as if we choose like -1 squared is 1 in parentheses. So we still get the same answers. They still have the same height values. And we get this beautiful curve. Oh, it's amazing. It's amazing. So that's what our parent function looks like. Now, every drawing that we do today is going to be this graph, except transformed. So let's do a quick refresher on those transformations. Remember, generally speaking, and this was from 1.2, generally speaking, when we were transforming, anytime we added something outside of the function, that means after the square, we would shift this up c. Anytime we subtracted something, as long as c was positive, we would shift it down c. Right? So positive, assuming c is greater than 0, adding c shifts the whole graph up c. It's like sliding it up. Subtracting c shifts it down c. If we add or something before, like we took the absolute value with our function, we added something that actually was a shift to the left, c units, and subtracting was a shift to the right, c. So remember the things that happen on the inside. Inside, we think horizontal. We think it kind of behaves the opposite of how you would imagine. So adding moves to the left, subtracting moves to the right. Let me grab a quick sip. Okay. All right. And then when we negate the function, that will reflect over the x-axis, or flip it, as we might say. And c is a vertical, you need to say vertical stretch or compression. Okay, vertical stretch or compression. Okay, fantastic. And we're going to go over all those. First, let's get warmed up. Let's get warmed up with what we did with the absolute value bars. Okay? Remember our parent function. It's real easy to do. The parent function for the absolute value function looks like this. Okay. Now this is not our graph. This is our parent function. Okay, so what is the graph of x equals, absolute value of x minus 4 and absolute value plus 3? Let me take a look. Well, we're going to take this graph and we're going to shift it to the minus is left. I'm sorry. Minus is to the right 4, and this is up 3. And we can go back and we can reference this if we need to. So we're shifting this to the right. So really just pick a reference point. I'll pick the vertex. We're shifting the vertex to the right 1, 2, 3, 4, and up 1, 2, 3. And so our actual function is this one right here, this one in green. We graph it all the way across our graph, across our coordinate plane. Make sure we fully understand the shape of what's going on. So there's our parent function, right? All right, cool. So we shifted to the right 4 and up 3. Okay, you guys try this one on your own. See if you can figure it out. We'll come back in just a sec. Okay, here we go. So we're going to take our parent function, which I'm just going to put in dots. Got our parent function. Remember, that continues all the way across. Now, what are the transformations? Add means go to the left on the inside. On the inside, it means go to the left. Add on the outside means shift up. And this negative means reflect. Now, what order do these things happen in? Technically, it's the shift to the left first. You follow the order of operations that you would do with the number if you plugged in for x. If you plug in 1, you do 1 plus 2, which means shift to the left 2. Then the next thing you would do after you take the absolute value is negate. So you're going to reflect and then shift up. So here we go. Left 2. You know what? Actually, instead of doing this, you can do it that way. You can write out all those, but there's a much faster way. That's just to take this vertex, shift the vertex left 2 and up 5. And since this is negative, but it's a negative 1 out front, it's going to have this exact shape, except it's opening down. So we're going to put that all the way across our graph. Go from there. Sweet. Sounds like an intense episode of Paw Patrol up there going on. Alright, cool. Hopefully you got that right. If not, maybe the next one. Alright, so how is this related? This is the same transformations, right? We have a -4 on the inside, +3 on the outside. But instead of having the parent function be the absolute value, the parent function is the quadratic parent function. So we're going to be taking those, first those perfect squares, 1, 4, 9. Well, that's way off the graph, but 1 squared is 1, 2 squared is 4. We're taking those points and we are going to apply the same transformations to get our answer. So we're going to take the vertex, start with the vertex, shift it to the right 4, and then we're going to shift it up 3. So vertex right 4, up 3, and then you just draw the exact same shape that you had, because our a value, or the thing that's out in front of our parentheses, is just a 1. So since there's just a 1 there, it has the exact same shape. This is our graph. Exciting. Now, how does that compare to the absolute value one that we did? Well, it has the same vertex, right? Over 4, up 3. You're just moving it over to a spot. This is directions for moving the quadratic. That's it. And our vertex is this point right here. The vertex is 4, 3, which you can kind of see in our relation, in our function here. Okay, let's take a look at this bad boy. Take a look at this bad boy. First thing I'm going to do is I'm going to kind of transform it. I'm going to write it in terms of keeping this negative in front of the parentheses. I'm going to put my constant at the end, because that's just a good way to think about it, and this is how we're used to observing it. So these two things are exactly the same. Let's go through and let's talk about the transformations of the function in this case. So this is, I see my squared, so I know that my parent function is y equals x squared, which again looks like that. Now let's talk about the transformations that have taken place. +2 means left 2. This means up 5. Shift. This negative means reflect. Now, if you look back at the example we did, reflect but keep the shape. It's the same shape, it's just been reflected. If we look back, it's the same exact transformation that happened here. So what's going to happen to our parent function? Well, we're going to take my vertex. I'm going to shift to the left 2. I'm going to go up 5. My new vertex is right there. Now I'm going to graph this red shape exactly, except it's facing down. So I'm going to go over 1, down 1, like so. Over 1, instead of going over 1, up 1, since this is negative, I'm going to go over 1, down 1, over 2, down 4. And since I have room, I had a lot of people in class when we were doing this that were just graphing this and stopping. Don't stop there. You have to graph all the points that fit on the graph. So, for example, 1 squared is 1, 2 squared is 4, 3 squared is 9. So when I go over from 3, I'm going to go down 9. And that will give us our shape. Boy, it's so beautiful. It's kind of funny. You look at this and you know that it's something. It's like your brain understands what it is. It's a shape we've seen, because we've seen things thrown in the air. We're used to this shape. It's written into our blood. Oh, how are we doing on time? Dang, I'm cruising. All right, we're going to wrap this thing up. So we've done these couple. Now these are pretty straightforward. The only transformations that we've had is a shift to the left or right. We've had a reflection, but that's it. We haven't done any stretching. I want you guys to try this one on your own. Go ahead and give it a shot. These are, I think, a little out of order from your notes, but that's okay. You try this one on your own. We're going to come back in just a sec before we do the stretches. Okay, here we go. All right, this one should go quick. My parent function, remember, y equals x squared. Looks like the blue dots. Okay, we have a shift plus 3. Plus 3 means left 3. And we have a reflection. So we're going to take this, we're going to shift it to the left 3. And we're going to reflect that downwards. So over 1 up 1, over 1 down 1, over 2 up 4, over 2 down 4. It's the same shape but upside down. Cool. All right. So let's recall my parent function for the absolute value function is v, right? It's just the line y equals x, but we've taken all the negative values and flipped them up onto this side. Okay, so there's my parent function. So what does the line y equals 2 times the absolute value of x do? It is a vertical stretch. Some people are confused and think it's getting pinched in. It's not getting pinched in. What we're doing is we are taking the points and we are doubling the heights. We are doubling the heights. We're stretching it up. So double 0 is 0. Double 1 is 2. Double 2 is 4. Double 3 is 6. And we've gone over this before. All right, so my question to you is, if you understand this shape, that's really what's important. Can you manipulate the shape of a function? Can you take the parent function and manipulate it based on this value on the outside of our function here? Okay, so let's take a look. How is this function 2 times the absolute value of x minus 3 and absolute value minus 4? Okay. How is this different from this? Well, it's the exact same shape. It's just been shifted to the right 3 and 4. So you can just take that same shape that we just drew, shift it over this way. And that's it. Easy peasy, lemon squeezy. Grammy's eating all the pretzels up the stairs. Not going to be any left. I can make this video fast. Get a drink. All right, let's go. All right, so now we're going to unleash, I'd say like it was like 80% of the force on a quadratic. So what does 2 times x plus 1 squared minus 4 look like? Again, I'm going to think about that parent function. Graph this 1,000 times. You'll never have to graph it again. And there is one over here up at 9. Just know that it curves up pretty quick. Yeah, so what's happened here? We got a couple transformations. We've taken this shape. I'm going to take my vertex. I'm going to shift it. Plus 1 means left 1. This means down. I like writing this because it helps me remember. And then we have a stretch. The stretch is it's a vertical stretch by a factor of 2. So basically, so I'm going to take my vertex, I'm going to shift it to the left 1 and down 4. Left 1 down 2, 4. So my new vertex is going to be right here. And then normally I go over 1 up 1 on my parent function. Since this is positive, I'm actually going to go over 1 up 2. Normally I go over 2 up 4. So on this I'm going to go over 2 up twice as far, right? Twice as far I normally go. Twice 4 is 8. So I'm going to go over 2 up. 2, 4, 6, 8. Okay, that's it. It's that easy. You guys give this one a try. We got left? Got a handful. Alright. Yeah, you guys give this one a try. See if you can get it, and we'll check back in just a sec. I'm going to do it real quick. Alright, so I'm not going to graph the parent function this time. I'm just going to remember that I'm taking my vertex 0, 0. Left, minus 2 means I'm going to the right 2 and up 3. But this thing is not opening up, it's opening down. So parent function is normally over 1, up 1. I'm going to go over 1, down twice as far, which is down 2. And then I'm going to go over 2. Normally I go over 2, up 4. I'm going to go over 2, down twice as far, which is 8. That is awful. All right. Got to power through. And the last one. This one's a little tricky. I'm going to rewrite it as y equals the absolute value of x squared plus 5. So here, since there's no parentheses there, there's no left or right shift. So with this one, what are the two transformations? We have a reflection and we have a shift up. Which one happens first? Follow the order of operations. Here's my parent function. The first thing I would do is reflect this. I would reflect it. Then I'm going to shift it up. So it's this thing, shift it up 5, right? But it's opening down. So, and it has the same shape as the parent function. Over 1, down 1, over 2, down 4, over 3, down 9. That will do. Now, on these last 3 examples, it wanted, I didn't do this, but it wanted us to find the vertex. So the vertex here, and label it, the vertex here is 0, 5. Can we see that in the equation? Well, I could rewrite this equation as negative x, x plus 0 squared plus 5, right? Then it's present. You can see it there, and this doesn't change anything because 0 plus x is still 0. These are the same equation. I've just added a 0, right? So you can see it if you can see the vertex in that equation. We can see the vertex. This is the vertex 2, 3. It is present here. And you can see the vertex here, which is negative 1, negative 4. Now, what you may notice a pattern between the left and right shift here, or looking at the shifting and looking at the vertex. And that pattern is that the numbers that are on the inside, the y value is always the vertical shift, right? The y value of my vertex, I should say, is always the vertical shift value. And the x value of my vertex is always whatever we're adding or subtracting, but opposite. So it's positive here, so it's negative in this case. And it's negative here, so it's positive in this case. And that gives us this rule that a parabola with vertex h, k can be written as y equals a times x minus h squared plus k, where h and k are the vertex, or h and k are the coordinates of the vertex. Now, a here gives us the shape of our parabola. H and k give us its location. So, you can quickly look at something and figure out what the vertex is. You can grab it directly from the equation. So, for example, the vertex here, the vertex is, well, what are we subtracting? 6. So this thing's always the opposite of what our actual vertex is. It's negative in the equation, it's positive over here. 6, 3. All right, how about this one? All right, our vertex here is, what are we subtracting? Well, this is minus negative 7, or we could just know, hey, do the opposite of what's present, so that's negative 7, 1 is our vertex. Okay, so you can see that here. So what these questions are asking is saying, giving an equation for the quadratic function of this form, where we know that the shape is either positive 1 or negative 1. So What means it has the same shape as the parent function. So it's either the parent function or the parent function reflected. All of the answers are going to have that a value. And just so you remember, we kind of talked last time about opening up and opening down. So I say, when we say opens up, so we mean this shape. Okay, opens up, opens down. Okay, opens up is when a is positive, opens down is when a is negative. So how do we write this? An equation of a parabola that has this vertex and opens up. If we know its a value has to be this. Well, what that looks like is it's going to look like y equals, well, a is opens up, means a is positive, so a has to be 1 times x minus 10 squared minus 6. So the x1 is always opposite. Okay, and then this example is a little different. It doesn't say whether it opens up and down, but it says it has a maximum value. So what that means is our parabola is coming up like this, and the maximum value is at the x value, -6. So it's saying this is x equals -6. We have a maximum value right here. That's kind of our axis of symmetry. And that maximum, the maximum or minimum, that's our vertex. And the maximum value is 18. So our vertex is -6, 18. So it's given us that information. Since it said it was a maximum, I know it has to open down, and a has to be less than 0. So we can write our equation as y equals -1, because our direction said -1. X minus -6 squared plus 18, or if you're real clever and you picked up on it quickly, this is just going to be the opposite, so x plus 6 squared plus. All right, ladies and gentlemen, that's the video. We'll see you next time. Thanks for watching. Keep working hard.